Hello, welcome to your numeric operations review help video. Okay, we're going to just jump right in. I'm going to go through each question, each of the 10 questions, and kind of explain how to do them so that you guys can get a good review in. So here we go. So this question number 1 says divide. Write your answer in simplest form. So we're going to go ahead and divide. I'm going to show you 2 ways. The first way is called the diamond method. Okay. So what this is if we have a division problem, we're going to draw a line starting with the first numerator of the first fraction, and we're going to draw it to the second fraction's denominator, and then we're going to draw it up. Okay, and what that means, we're going to go ahead and multiply those together. So we're going to do 8 times 8, that's 64. Okay, and then we're going to do 7 times 5, and we get 35. Okay, so that's how you would do the first method. That's the diamond method. Now, the problem is we need to write our answer in simplest form. This is not simplest form because the top number is bigger than the bottom number. So if the top number is ever bigger than the bottom number, we do have to simplify it and change it into a mixed number. So we're going to do that by taking 64 and we're going to divide it by 35. 35 can go into 64 only once, so 1 times 35 is 35. We're going to subtract. So we can't do 4 minus 5, so we're going to go ahead and borrow from the 6 and make this a 5 and make this a 14. 14 minus 5 is 9. 5 minus 3 is 2. Now we're stopping there. We get a remainder, and with the remainder we're going to make a fraction out of it. So we're going to do 29 over 35. So our answer would be, oh man, my pencil keeps breaking. 1 and 29 35ths. Okay, so 64 35ths is the same as 1 and 29 35ths. Okay, now this would technically be a correct answer, but if you don't see that on a test, that just means you have to make sure to change it into simplest form. Okay, now that's the first method. The second method that you may have been taught is the keep, change, flip method. Okay, or I've heard different things, but basically you're going to keep the first fraction the same. You're going to change the symbol, so instead of division we're going to change it to multiplication, and we're going to flip the second fraction, 8 over 5. Okay, and then we can multiply straight across, so we do 8 times 8, which is 64. 7 times 5, which is 35. Okay. Okay, and then again, you'd have to do this, and I'm not going to show you that division problem again, but if there's a bigger number on top, you would have to divide to get a mixed number. Okay. All right, let's move on to number 2. Number 2, we've got 2/3. Oh, it says divide, write your answer as a fraction or mixed number in simplest form. We've got 2/3 divided by 3 and 1/2. So if we have a mixed number at all, we always have to change it. So we're going to do that by doing around the world. Now, around the world, you multiply first and then you add the numerator on top. So we've got 2 times 3, which is 6. 6 plus 1 is 7. So our new problem is 2/3 divided by 7/2. Okay. So again, you can choose what method you like. I'm going to do the diamond method, but you are welcome to use the keep, change, flip method as well. You get the same answer. So the diamond method, I'm going to take 2 and I'm going to times it by 2 and put it on the top. And then we've got 3 times 7, put it on the bottom. And our answer is 4 over 21. This is the simplest it can go because 21 and 4 don't have a common number to divide by. Okay. Okay, let's look at number 3. It says a road crew must repave a road that is 3/4 miles long. They can repave 1/48 miles each hour. How long will it take the crew to repave the road? Write your answer as the simplest form. Okay, so if we have a length that that the road crew is supposed to repave, okay, and they can only repave a little bit at a time, we're trying to figure out how long it's going to take us. So we're going to take 3/4 and we're going to divide that by 1/48 because that's how much they can get done in an hour. Okay. All right, so again, you can choose whatever method you want. You can do the diamond method or the keep, change, flip method. I'm going to do the diamond. So we've got 3 times 48. I don't know that off the top of my head, so I'm going to come over here and just do 3 times 48. And we've got 3 times 8 is 24, carry the 2. 3 times 4 is 12, plus 2 is 14. So that's going to be 144 on the top. Then we've got 4 times 1, which is 4. And now my answer is not in simplest form because there is a bigger number on the top than the bottom. So we've got to do 144 divided by, divided by 4. Okay. Okay, so 4 can go into 14 3 times. 4 times 3 is 12. We're going to get 2 left over. We're going to bring down the 4. 4 can go into 24 6 times. 6 times 4 is 24, and we get 0 left over. So now, I keep seeing this, but if there's no remainders left, your answer is just going to be a whole number. So this is our answer. We've got 36. Now, what does 36 mean in this scenario? It means it's going to take them 36 hours, right? Because it tells us that it's each hour, right? It's going to take 36 hours for that crew to repave the road at the rate that they can do that. Okay? Okay, moving on to the next one, we're transitioning into decimals. So we've got 8.97 divided by 7.8. What we're going to do is set up our division problem, and the first number that's listed always goes in the division box. And I'm going to put this up even further up here so we can have lots of room. Okay, now, a rule that we have to remember is that whenever there is a decimal on the outside and on the inside, right? On the outside, we have to move it over as many times as we can to make it a whole number. So in this case, we only need to move it over 1 spot to make it 78. Okay? And then whatever we do to the outside, we're going to do to the inside. Now, when we move decimals over like that, that's basically just saying that we're dividing it by, we're timesing it by 10. That's all we're doing when we move the decimal. Okay? Okay, so then we moved it over this way, so I'm going to move the decimal up. Okay, that placement's very important. Next, we have to do 78 into 89. Well, I know that that's only one time. 1 times 78 is 78. We're going to subtract. We get 9 minus 8 is 1. 8 minus 7 is 1. And I'm going to bring down the 7. Okay, 78, let's see how many times it can go in twice. Let's see if it can go in twice. That's what I was trying to say. Okay, 2 times 8 is 16. 2 times 7 is 14, plus 1 is 15. Okay, 156 is way too big for 17. So again, 78 can only go into 117 one time. 1 times 78 is 78. We're going to subtract. We can't do 7 minus 8, so we have to borrow and make this a 0, make this a 17. 17 minus 8 is 9. Can't do 0 minus 7, so we have to borrow, make this a 10. 10 minus 7 is 3. Okay, now, just a reminder that when we are dealing with decimals, we can't have remainders. Like what we did up here, we can't have remainders. What we end up doing is we have to remember that there's multiple... Hi! Okay, so sorry, the janitor just came in. So, okay. So we can't have remainders with decimals. What we end up doing is just keep going. So we bring down an imaginary 0. Okay, so we've got 78 into 390 now. All right, 78, I'm going to try and think of a number times 8 that ends in 0. So I know that 8 times 5 is 40, so that ends in 0. So I'm going to try and times 78 by 5 and see if that's too high or too low. That's kind of how my brain works. You can always just start like, you know, we did 78 times 2 already. You could start at 78 times 3, right? Let's see. So 5 times 4 is 40. 5 times 7 is 35. Plus 4 is 39. So look at that. It goes in perfectly 5 times. So we're going to put a 5 up here. 5 times 78 is 390. And we get 0 left over. So we're done. So this answer right here is 1.15. Okay. All right. Next up, we have another word problem. So it says there are 6.86 grams of sugar in 7 servings of grapes. How many grams of sugar are in a single serving of grapes? Okay, so we're talking about 7 servings of grapes has this many grams of sugar. We need to figure out how many grams of sugar are in just one serving. So we're going to take the amount of sugar in these 7 servings, and we're going to put this in the box, and we're going to divide that by the 7 servings, and whatever we get is going to be the amount of sugar that's in one serving. So here we go. There's not a decimal on the outside, so what we're going to do is just bring the decimal straight up. We don't need to move it at all. Okay. 7 into 6, 0 times. 7 into 68, it goes 9 times. 9 times 7 is 63. 8 minus 3 is 5. And then we're going to bring down the 6. 7 can go into 56 8 times. And that gives us none left over. So that means that there's 0.98 grams of sugar in 1 serving of grapes. Okay? Okay, we're moving to the back. So we're on question 6. It says to multiply. It's already lined up for us nicely. So what we're going to do, I'm actually going to move this. There's just not a ton of room right here. I'm going to actually move it up here so that there's more room. Because this is a 3-digit multiplication, right? So we're going to have lots of numbers going on. Okay, here we go. So we're going to start with 6. 6 times 8 is 48. We're going to carry the 4. 6 times 6 is 36 plus 4 is 40. Drop the 0, carry the 4. 6 times 7 is 42 plus 4 is 46. Sorry, my brain was having a brain fart there. Okay, I'm going to cross off these little guys. We're done with the 6. So because we're done with the 6, we're going to drop a 0 for them. And then we're going to do 0 times 3 numbers. That's just 0, right? So we're just going to put zeros for all those. Okay, we're done with that number. So because there's 2 x's now, we're going to put 2 zeros. 4 times 8 is 32. Carry the 3. Oh, man. 4 times 6 is 24 plus 3 is 27. Carry the 2. 4 times 7 is 28 plus 2 is 30. Okay, we're going to add them all up. We've got 8, 0, 8, 11, carry the 1, 1, and 3. Okay, now, we have to remember to put the decimal back into our answer. So we're going to do 1, 2, 3 numbers. So we're going to start here and we're going to go back 1, 2, 3. Okay, so our answer is 311.808. Okay, number 7 says a cable repair person has 8.7 meters of wire. Suppose each meter of the wire weighs 2.8 ounces. Find the weight of the wire. So if this is per ounce, and we know we have this many meters of wire, we're going to need to do sorry, per meter, I meant. So we're going to need to do the amount of meters the whole wire is times how much the weight is for each meter. So we're going to do 8.7 times 2.8. Here we go. 8 times 7 is 56. Carry the 5. 8 times 8 is 64. Plus 5. We've got 69. Cross off the 8 and the little 5. We're going to drop a 0. 2 times 7 is 14. Carry the 2. 2 times 8 is 16. Plus 2 is 18. Okay, now we're going to add. We get 6 plus 0 plus 6 is 6. 4 plus 9 is 13. Carry the 1. 1 plus 6 is 7. Plus 8 is 15. Carry the 1. I feel like I definitely did something wrong here. Hold on. Okay, so sorry. I just barely paused the video and I looked at my mistake. So this is what my mistake was. See, everyone makes mistakes, so it's a-okay as long as we're fixing them, right? So I did 2 times 7 is 14, and instead of carrying a 1, I accidentally carried a 2. So that would make this 17. Okay, so we've got 13 plus 1 is 14, carry the 1, and then we end up with 24.36. Okay, next up is number 8. We've got find the greatest common factor of 36 and 42. So I'm going to go ahead and break these two numbers down. So we've got 36 and 42. I know that 6 and 6 can go into 36. And then we were going to break 6's down into 3 and 2. Okay, for 42 we have 6 and 7. 7's a prime number, so I'm going to circle it. And then we've got 3 and 2. Okay, so if you notice, yes, they have 3 and 2 in common, right? But that means that they have 6 in common. That's the biggest. So let me show you the Venn diagram to show you why the GCF would be 6. So, of course, we're going to go ahead. I'm going to cross off 3 and 2 because I know that they both have those in common. And we're going to put those in the middle. And then we end up with a 3 and a 2 over here and a 7 over here. So the GCF is everything in here multiplied together. So 3 times 2 would be 6. So the GCF would be 6. If we needed to find the LCM for these two numbers, we would just multiply all of these together, and that would be our LCM. Okay, but our GCF would be 6. Hopefully you were able to just look at those two numbers and like understand that 6 is the biggest number that can go into both. Okay. Okay, the next one, we've got the least common multiple of 24 and 6. Remember, multiples are just the times table facts. So 6, 12, 18, 24, right? 24, 24, 48. I don't know what the rest are. If you notice already, a lot of these that you get asked, you can look at the smallest or biggest number and you can see if so like for example, I know that 6 can be multiplied by 4 to get to 24. So that would be the least common multiple because they both have that in common, right? And that's the smallest number that they both have in common. And there's another way to do it. You can do the Venn diagram way. So you can break these two numbers down, put them all in the thing, okay? You could also do the upside down birthday cake. So you could do 24 and 6. You could pull out 6, because 24 and 6 can both be divided by 6. 6 times 24 is 4. 6 times 4 is 24. 6 times 1 is 6. And then the LCM is just multiplying all of these together. So it would be 6 times 4, which is 24 times 1, which is 24. So our LCM is 24. Okay. All right, last but not least, we've got factoring. Find the greatest common factor of 72 and 27. I'm going to go ahead and just break down my numbers And already, right off the bat, I can see that the biggest number that they have in common is 9. See? So you don't even need to break down it entirely. So 9 is my greatest common factor. Now when you factor something, you're going to have, it's going to look like this. It's going to have parentheses. Okay? So when you factor from an expression that looks like this, you're going to take the GCF. So we found that it was 9. And then we're going to put a factor times the GCF to get to these two numbers. So for example, we've got 9 times something will give us 72. I know that 9 times 8 gives us 72. And then 9 times 3 gives me 27. So our factored expression would be 9 parentheses 8 plus 3. Now Alex is really weird, and they put the times symbol there to just help you remember that the parentheses mean that they're multiplying together. Okay. Now later on in the year we are going to be learning the distributive property, and this will make a little bit more sense. But for right now, that is how you factor. You just take the GCF out and then you put the factors that are left inside the parentheses. Okay, you guys, that was your math test review for numeric operations. I hope you will be able to study this a little bit more, and I hope you guys come prepared for your test. And yeah, thank you for watching.